Okay, thank you for coming. It's a real honour this for me. I joined OWASP in August last year, and to be giving a talk at an OWASP gig like this in under a year of being a member is a real honour. So I'm very grateful for the invite, and I hope I do it justice. So my talk is about web application firewalls. So a quick show of hands, who is aware of what a web application firewall is? Okay. And keep your hand up if you implement one in your web applications. One. A couple, few people. Awesome. Great. Okay. Before we get into the detail, a little bit about who I am. I'm Mike. Hi. I'm also known as AppSecBloke on Twitter. I twit and tweet. I talk a lot on there. I'm probably on a few mute lists, I would have thought by now. I'm also a blogger. I've been blogging for, again, just under a year. Writing about my experiences of the InfoSec community, the industry, where I came from. I wasn't always in InfoSec. I also talk about some of the experiences I've had in my place of work around solving problems around security. And some of the problems that still persist that we're trying to fix. So you can hit my blog, have a read. I can get quite grumpy. Scott will know this. I do like to weigh in a little on Twitter particularly when the subject of why do we need HTTPS everywhere crops up, which is a burning topic at the moment. I'm in the camp that we need HTTPS everywhere and there are zero excuses for it. I know for a fact Scott and Troy and people like that all agree, and we are proponents of that as the right way forward. And it ain't just us, large organisations are pushing for this as well. That's an example of how I can get a little bit cheesed off at times. I'm a helper. I always take great pleasure from helping other people and developing other people. I've given a bit of support to a few people in the audience over the past few months. Just encouragement, sharing some of my experience. My DMs are open, which can sometimes be a bit of a death warrant, but anybody want to get in touch with me on Twitter, please do. I'll always reply as quickly as I can. And I'm now a speaker. Now, I've done the B-side circuit throughout the whole of 2018. And it's kind of been a little bit of a climb up a hill. I applied for B-sides leads, didn't get that, but did get invited to do a lightning talk at the sort of B-sides bit on the evening before. Applied to B-side Scotland, didn't get it, but got a reserve speaker, which is a bit weird because you're like a sub that never gets brought on. But it was great because the people up there had really treated me really well, really enjoyed it. I then put a rather speculative talk application into B-sides London, and lo and behold, I got it. So my first actual talk outside of my place of work was B-sides London on June the 6th, which was this talk I'm giving you guys now. It was a big deal for me because it's been a bit of a journey, and that was kind of like the climax of that journey for me. And I've written about that on my blog. You can have a read of that if you like. My day job is I'm an InfoSec guy working for a ISP. The ISP is Zen Internet. I'm not going to go into any more detail because I know these things aren't about pitching, but I work for Zen Internet in Rochdale. And I'm also an OWASP member. Who in the room is an OWASP member? Wow. Okay. Who in the room is a paid OWASP member? Cool. 3 of us. That's actually indicative of OWASP membership globally. Okay. So it has around 46,000 contributors, participants, people that have got OWASP relationships and things like that. But actually, there are the membership, the real membership, is a fraction of that amount of people. About 1,600 people are actually paying their subscriptions. And I would encourage everybody to actually get involved and contribute financially to the foundation because there are really good things that happen as a consequence of it. So who's heard of OWASP Zap? Yeah, as a web application scanning tool. Awesome. Juice Shop, familiar with Juice Shop? Yeah. That and myriad other projects that the OWASP Foundation actually get off the ground are funded because of the contributions that we make as paid members. So that's really important. An individual member is $50 a year. $50 a year is about £35 sterling. If you're a student, it's $20 a year, which is about £14, something like that. Now for that you get The benefit of being able to contribute to something big, the benefit of gaining access to people that are exactly like you around the world that are trying to solve problems around web application security, that's a big thing, to be part of something, be part of a really big community. Projects get off the ground, OWASP's app becomes a thing, OWASP's app is constantly developed and kept up to date. The community, the marketplace around OWASP's app is thriving. There are new things being added to it regularly. That's because people have got the funding that comes out of these pots that we create. And if that wasn't enough, you get an OWASP.org email account. Now that lends a lot of credibility, actually. I've stopped using a lot of email accounts that were loosely related to security and now just use my OWASP.org account, because it adds a level of authenticity to you as an individual professional within the information security community. So I would encourage you to do that. Not only do you get an OWASP.org account, you get a G Suite account, which is pretty cool because it's got unlimited storage. So you get a Google account with all of the bells and whistles that come with it and endless storage as well, which is kind of cool. I pay £6 a month for that privately with Google, so it's cheaper to get it with OWASP. Okay, enough about that. A preamble. That was a preamble. This is another preamble. Teeth are kind of firewall. Now, teeth are a kind of firewall. If you're in an open top vehicle at speed, stop flies getting in. If you're eating food, they're a first line of defense before you choke to death. I lost a tooth. I lost a tooth at OWASP Glasgow. Right? Any of that kind of ring true? Anybody been to Glasgow? I'm from Scotland. I can get away with jokes like that. It came out at, just after the conference. My dentist said, let it come out, and then in a few months' time, we'll sort it all out for you. So originally, it made talking quite difficult, and it's still a little bit annoying, but there you go. Okay, WTF, what we're here for. What is a web application firewall? So fundamentally, it's a layer of defense between the bad guys on the internet, on the web, and your web applications that are sat on the internet. And ultimately, it's a layer of protection against them compromising data. That's what it's all about. Against them defacing a website, against them taking down a website, and things along those lines. In the way we've implemented our WAF, it's a way of controlling how people get to your web applications. We've got a lot of web applications, and I'll cover that in a little while. It's a way of being able to see what's going on. I'll come on to that again in a little while. We can monitor everything. Anything that generates a log via our web application firewall, we ship those logs and we centrally manage them, and we can see stuff going on. And it's a legitimate component in your arsenal of web application security. Okay, don't let anybody ever tell you otherwise. It has validity. What WAF isn't, it isn't a complete solution. It's not a turnkey. Okay, it's not, oh, we've got a WAF, everything's cool. It's not a reason for devs to bin off secure coding. It absolutely isn't. And I'll give you an anecdote. We have 55 web developers and 10 software architects that work at Zen. I guarantee none of them know exactly what the WAF is doing. The WAF was conceived by myself and our platform systems engineering team. We have relationships with our developers, but we haven't told them precisely what the WAF's up to. And it's deliberate, because while they're not entirely sure what it's doing, they can't be convinced that their software is going to be protected by it, which encourages them to be more diligent around web application security. It ain't an excuse not to patch things. I've written a post about patching things. Anybody that's watched the news, the majority of very large data breaches that have happened in the last 2 or 3 years have been down to out-of-date components, and OWASP has got a thing on using components with known vulnerabilities. So whether it be Equifax with an out-of-date version of patchy struts, no excuse to not have that patched. The patch was made available months ahead of that, etc., etc. It's not an excuse not to do that. And it's obviously not an opportunity to tell your boss that everything's A-OK. Yeah, the WAF will take care of that. You can't do that. It's not got to be considered a total solution. Okay, so how did we get to having a WAF? We'd had a really bad days actually. So on Saturday, the 16th of September 2015 at 12 noon, Zen Internet went off the internet, which for an ISP is a pretty crap look, yeah? So somebody was denial of service attacking our entire .zen.co.uk website space assets. And it was a bit of a mixed job. It was a TCP SYN flood, it was random UDP craziness, it was the HTTP pingback attacks that were hitting us from pwned WordPress implementations. It was a mess. And part of the reason that was happening was because the origin servers were directly addressable. They weren't coming in using DNS, they were hitting the IP addresses of these boxes, and they were blasting us. And it was incredibly embarrassing. So we had a few things we need to make sure we didn't have happen again. So keeping our critical web apps up. So as an ISP, we've got to be online, right? We've got to at least have our marketing website up. We've got to at least have the capability for people to place an order or to contact us or to pay a bill. All of these business critical things that we needed to keep up. We needed to somehow block malicious requests. We weren't doing it at all at that time. We needed to firewall off access from the web to our origin servers. We needed better monitoring. We had a couple of dashboards doing a few things, but nothing sophisticated. It certainly wasn't providing us with the comprehensive coverage that we needed. And we needed to understand our traffic better. You know, we're seeing HTTP requests from all over the world, but for us it was just another HTTP request. So we needed to be able to look at it in more detail and do some analytics. Okay, so we were already using AWS, Amazon Web Services. A little corner of the business was doing some experimenting with Route 53 DNS and EC2 and S3 buckets. You all know S3 buckets, right? Yeah, they're another security headache. So we partnered up with a bunch of guys and gals from another department, and we set a project to try and stand up our main zen.co.uk website in AWS, and then try and blast it off the internet and see whether we could withstand the attack. We set about doing, and we successfully did that, and it gave us the proof of concept that we were able to go ahead and start doing it with other things. So we use AWS extensively. I'll come on to the precise tech in a little bit. We use reverse, so you can't see the origin web servers. You hit the zen.co.uk address, it goes through a reverse proxy, and then that proxies a request down to the origin web server. It's the right way to go. We then firewall off any direct access to the origin. We route requests. I'll come on to that again. We screen requests, so we now look at what that HTTP request looks like, head and body. We now look at things like the user agent string. We now look at what the URI is in the request. We now look at the country of origin of the request, and so on and so forth. And it enables us, based on that screening, to then handle a request. We can ship it somewhere. Okay, we can send it to one place or another, depending on what it looks like. And we've got tons and tons of better monitoring. So we use Route 53's native DNS service. So whenever you get a request, Route 53 handles the DNS. It does all the IP lookup stuff. It looks at your geo-IP location and all that kind of thing before passing your request on to a stack of choice, which I've got a nice little graphic and a rough graphic to show you. We're using their elastic load balancing technology. So we talk about denial of service, well, we scale out now, and we're using all of Amazon's native load balancing technology. Not strictly to do with WAF, but we use Amazon's Cert Manager, so that means we don't have to worry about managing certificates. Another area where I'm grumpy, and so is Scott, is around certificates, but we're grumpy on the same side, right? Yeah. We are. But we don't have to worry about that because Amazon deals with our certs. We're experimenting, well, we're not, we're now running in full production Nginx as our proxy, which to an attacker might look a bit weird because predominantly our technology stack at Zen is ASP.NET. But when you look at our websites, you get served back something from Nginx, and that's kind of like, what the hell, what's going on here? But that's great because it's a really light footprint, it's really quick, and it's ultra configurable, and we can do lots of good stuff with it. We also use HA proxy, and we use that because we have a lot of things that rely on NTLM auth. And our implementation of Nginx doesn't support NTLM auth at the moment. HA proxy does. So we have the majority of stuff going through Nginx and a few bits and pieces over there going through HA proxy. We utilize an IP block list, so we're letting somebody else do the work. So we look at House and OpenBL and Tor exit nodes and all that kind of stuff. When your IP comes in, before it gets anywhere near the application, we see your IP, it's on a block list, we drop your connection. So that's just one of the things that we do. We do other stuff, and some of it I don't even know because it's hot off the press, and some of it we just want to keep a bit of a lid on. We don't want to air all our laundry in public. Our actual handler is NACSI. Nginx, anti-cross-site scripting and SQL injection, and OWASP top 10 generally. That's what that does. And that's designed to play nicely with Nginx. So that's what handles your SQL injection attacks. That's what handles your local file inclusions. That's what handles your cross-site scripting and all that kind of stuff. It's not signature-based. It's quite clever. It's quite adaptive. The only trick we have with it is we have to manage we have to do whitelisting of good requests that are perceived by NACSI as bad and dropped. Come on to that in a bit more detail in a bit. We also use fail to ban. I banned myself today, which proved it works. We're looking at Tenable.io's online scanning platform, and I forgot to whitelist the IP that it comes in on, and I got a ban for 4 hours. So luckily I was leaving work to come here. And we use Elk. Anybody familiar with Elk? Show of hands. A few people. Elasticsearch, Logstash, and Kibana. Really whizzy way of shipping a lot of disparate log files into a central indexing store and being able to build some pretty neat looking dashboards and analysis tools to work with that data. Really good. Okay, so what does it look like? It's a stylized diagram that a colleague of mine drew of the AWS stack. So you can see your request coming in here, Route 53 doing the DNS lookup. At this point, Route 53 determines your location and says, right, okay, you are from the UK and Friends. Friends being Ireland, Isle of Man. Yeah, we have a lot of AWS assets in Ireland. That's where our hosting region is. And we route your request there. But the first thing we do beforehand is we say, actually, is that .zen.co.uk site up? If the answer is no, we route you to our failover. And that failover stack is probably over-engineered because all it contains is a page saying, hey guys, sorry the site's down, one of our engineers is looking into it, and we'll have it back up shortly. But it's there. I think we were worried that we might have a lot of outages, so we built a fairly over-engineered stack to cater for it. Similarly, if you're from anywhere in the EU or the rest of the world, USA, then we look you up and then we send you down this route here. If we perceive you to be doing bad stuff, then we send you to the black hole. It's more a honeypot than a black hole because we don't sync all of your requests. We actually allow you get a 200 back, basically, but we see your request and we can use it for threat modeling, threat analysis. To an attacker that's running a script attack, they're going to think they've hit the bullseye every time because they're going to get 200s, and we do that deliberately. We also use T-potting, HTTP 418. Adrian and myself, who came up with this, thought the HTTP 418 was not used enough, so we T-pot people for various different reasons. And here, in the shadowy background, are our origin boxes. You can't get to them unless you've gone through one of these two routes here. Okay. So what does it actually look like? I couldn't be bothered redrawing this in Visio. I couldn't make it work in that other drawing tool, so I thought we'd just take a picture. Easier to explain. So here you are, and here's you coming in through Route 53. So we do an IP lookup. We work out whether the site's up or down. If your request is great, then you get down here, and here we look up your IP address. If your IP address is on any of these lists, the list is a lot longer now. Then we drop your connection at Nginx here. That's what happens. These are the elastic load balancers. And then if your request is great, you've come down one of these two routes, you'll end up getting down served by the web server. We've got Windows NLB going on down here. All is good. However, if your request contains anything dodgy, so let's just for argument's sake a simple apostrophe in the URL, then Nginx NACSI goes apostrophe in the URL, pass you to fail to ban, and ban you for 4 hours. Now, that might seem quite punitive, and we're still tuning it because obviously people do put things in URLs that they don't mean to do. But we've been doing this now for quite a long time, and we've not had a customer, a legitimate user, ever get in touch with us and say, hang on a minute, I can't see your website. So until someone objects, we'll continue to probably do what we're doing. Yeah. Again, pretty punitive, but yeah. Similarly, if anything looks like a script, any angle brackets or anything like that, then you get 4180 and then you get passed to the honeypot where we spot your request. Now, geographical IP management. we had a really big problem last year with our forum. Our forum is a third-party application that, well, it's fair to say the company that made it doesn't exist anymore. And we're in the process of getting rid of it, but it's still there, it's still up. And we're having a real problem with people creating spam accounts and then posting junk onto the forum. And they were predominantly coming out of Eastern Europe, Lithuania, Poland, places like that. And so we took a decision to actually block access outside of the UK to our forum using Route 53. So we reasoned that we only sell to a UK customer base, and so we reasoned that only UK customers are going to want to use our forum. It's a forum to discuss our products, our services, to have a rant about us as a company. So we've done that. We took that decision. So only UK IPs will be able to access the forum. Anybody Russian in the room? Cool. We had Niet. Dark, comrade. We're an ISP, right? And we're a hosting company, and we have a lot of traffic on our network. And we seem to have a hell of a lot of problems when political things happen. Okay? Maybe it's the fact that a political party hosts with us, or whatever. But we do seem to find that bad traffic follows things around a lot that's happening in the political sphere. And we noticed this happening a lot with Russia. When accusations about Petya and WannaCry all started surfacing, we started seeing bombardments from Russia. So again, we had a meeting and we decided to turn Russia off. Okay. So as far as Route 53 is concerned, Russia doesn't exist as a country because we were having so much trouble with them. Really bad traffic. Okay. But it gives you power doing this, real power, because if you're finding you're getting a geographically diverse denial of service attack at Route 53, you can actually turn those countries of origin off and let Amazon worry about it. It's cool. It's really good. And all of it is being, every box here effectively ships its log files into our Elasticsearch, into Logstash. Elasticsearch indexes, and Kibana allows us to build some neat dashboards and look at what's going on. So it's a perimeter. Okay. So bad requests are handled, modified requests. So anything that looks weird or shouldn't be there, we capture it, we drop it, we teapot it, we honeypot it. Yeah. But you don't get to where you want to be. We get rid of bots. We're pretty good at doing that now. We subscribe to bot lists and we look them up, and if we see it, then we kill you. Okay. Not perfect, because new bots get created all the time, so it's only as good as the lists that are kept up to date. But we don't keep those lists up to date. That's the important point. Somebody else manages that problem for us. Dodgy IPs are dropped. So we talked about Spamhaus and OpenBL and others. If you're coming at us through Tor, sorry, no good. Two types of person use Tor, generally. A security researcher, in which case you get it, you understand, or an attacker, in which case you don't care. Okay, so you can't hit us through Tor. You've got an iffy user agent. The user agent's sort of common clue that an attack's coming from a particular remote source. We get rid of them. You can no longer browse to our origin servers. You have to go through the reverse proxies. That's the only way you'll get there. If you're a country we consider a threat, then we can get rid relatively easy, much easier than we were able to do. We can see all the HTTP traffic because we're logging all the HTTP traffic. We're logging health checks at the ELB level. We're logging Route 53's DNS activity. We can see all that happening. Again, Amazon managing our certs is a bit of a bonus. It's really good. And we keep our websites up. Okay. It's not perfect. Right? Let's be under no illusions. It's not perfect. I've been very clear. It's not a panacea. It's not the answer to everything. So VPNs, yeah, if you're from Russia and you come at us from France, you're coming at us, that's fine. We have other handlers. We're looking at your URI. We're looking at your user agent and things like that. So we're going to handle you one way or another. There's still some manual work. So I talked about whitelisting in NAXI. A bad rule can break your app. If you've got a GUID that's got a word that unfortunately appears to be SQL syntax, then we're going to block, unfortunately. So we have to spend a little bit of time looking at common strings that appear in our URLs and make sure we're whitelisting them in the WAF. We don't have any machine learning or AI. I remember a talk that a guy called Gilad gave at B-Sides Leeds in January, and he was talking about how those guys in Israel are using machine learning and AI to adaptively evolve their web application firewall. It's almost like, right, switch it on and set it off, and look in from time to time just to see what it's doing, and take logging out of it. But actually, no configuration required. It evolves. It seeks out the behaviours of the bad actors, and it changes the way it behaves in response. Something on our mind. We're not looking at it really in earnest yet, but we will do. New threats need new analysis. We kind of get that. I think that's the same in pretty much any kind of walk of life. And we're always playing catch-up. There's always some new threat out there that we've got to try and figure out a way to mitigate. But this helps, really helps. And so, it isn't a total solution. I can't stress that enough. I saw an argument raging on Twitter a month or two back about, well, a web application firewall is only there for compliance. Yeah, that's absolute nonsense. Okay, it's not there for compliance. That might have been an attitude 5 years ago, 10 years ago, a box tick. No, it's a valid member of your web application security family. Okay, it's as important as hardening a server. It's as important as good network design and firewalling practices. It's as good as access control, and of course, good old new-fashioned secure coding practices, okay, which is what we're all about, right? It's a first-class component of layered security. Okay. Thank you. So, are there any questions?
Yeah. Did you ever think of using like a CDN provider as either on top of that or alongside it, or as a stopgap measure in the interim? It seems like it's like a really well-engineered solution for this.
Yeah, we couldn't afford it. That was the bottom line. We've got 374 web applications that are sat on the web. A combination of websites, web services, APIs, etc. And when we looked at Cloudflare back in 2015, and it was one of those slider scale of number of assets you want to protect up to the top, and then you're going to have to contact us. We contacted them, and it wasn't going to be cost effective for us. So as we've designed it, we've kind of ended up getting into bed with our own solution and bound ourselves into it. So breaking away from it's probably not something that we'd want to consider right at this moment. Yeah.
And even if they're only doing like basic scrubbing, it's like you just take some stuff away from that.
Yeah.
We'll just deal with the rest.
Well, I mean, we could look at something like that. But I think we've gotten into a situation where we've so finely tuned this technology for ourselves. Bear in mind, it's 2015 that we started on the journey, that we know it so well and we trust it so implicitly, and we love it fundamentally. Anything else? Yeah. Perfectly fine. Yeah.
As a proof of their seriousness and security.
Zen is changing a lot. It's always changing. But we got a new CTO in last year, and part of his brief was to raise the profile of our organisation in the industry generally, not just the telco industry or the ISP industry, but also technology generally. We do a lot of really good tech at Zen, and we want to tell people about it and encourage people. Ultimately, we want the good people to come and work for us. That's what it's all about. So this goes with their blessing. Richard Tang, our CTO, has read my blog, which is kind of surreal, and he thinks it's great, and he's trying to be more open about the workings of Zen himself. So, yeah, it gets a thumbs up.
Are there any benefits of using your WAF over CDN?
Quite possibly, yeah. CloudFront would probably be our CDN of choice because we're not bound in, but we are using so many native AWS technologies already. Then it will probably make sense for us to integrate CloudFront into what we're doing.
I mean, in terms of functionality, do you have anything that has benefit over using a CDN?
Not ourselves, no, not at the moment. Other than the fact that we've got Amazon's pretty vast infrastructure sat in front of our web applications, we're getting the benefit of that, but no, nothing at the moment. So it's a bloody audition. That's fantastic. I wasn't expecting that, but excellent. Okay, I'll wrap up because Liz is here, and her talk's going to be a hell of a lot more interesting than mine was. I have no doubt. @SetBloke on Twitter. Get in touch. I like to talk, but I like to share, and I like to get involved, and I like to get behind people that want to do the right thing. And @setbloke.com is where I blog my stuff. So thank you very much. No problem.